Hi, welcome to this video on bootstrap aggregation. This video is a follow-up to my previous videos on ensemble methods and random forests. We saw in ensemble methods how we can take multiple weak models and then somehow combine them to get a model which to in entirety is much more robust than any given single model. And if all of these individual models happen to be decision trees, then how the aggregation is called a random forest. We also understood how for a random forest or for this ensemble to work, why we would need each of the individual models to be a little different from each other. So with that being said, let's understand how do we grow these trees to be a little different from each other. Now this the most popular technique to do so is called bootstrap aggregation, or often chopped and used in short form as it's also called bagging. So in bagging, B comes from bootstrap and AGG comes from aggregation, and hence the term bagging. What this means is, let's say this is our data set which has m number of observations, that means m rows, and we have 10 features A to J. Now the way we create different trees using the same data set is by taking this data set and sampling from it with replacement. Now sample with replacement is, let's say we pick up one row and it came out 1. Then we put it back. We picked up another row. It was 32. We put this back. We take another sample. It was 69. We put it back. And in the same way we do it m number of times to match the size of the original data set. We need not match, but it's often what people do. They create data sets of same size. So we do this m number of times and we might end up with a data set which is almost like this. However, because we are randomly picking up observations, it might be possible to have repetitions in it, just because we are doing sampling with replacement. If you want to gain more intuitive understanding of what sampling with replacement is, I have provided link to a good article. It's just half a minute or a minute long read. I would suggest you go quickly check that link and come back to this video. So what we have done with bagging is, we have taken our data set and sampled with replacement to generate another data set. Now we do this n number of times to create n data sets from our original data set. Now each of this data set, imagine it just like a shuffled version of it, but instead of it just being a shuffle, it might also have certain repetitions because we sample with replacement. So generating new training subsets of original, each of same size, usually the size of original dataset, by sampling with replacement is known as bagging. Now by sampling with replacement, I repeat, some observations may be repeated in each subset. However, we may have number of different subsets now. So this data set would be slightly different from this data set. Now if you remember in our previous video on ensemble techniques, I would have told that tree inherently is very sensitive to structure of data, and what we have done is slightly modified the structure of data, which might lead to an entirely different branching mechanism for a tree. And because this data varies slightly, we might, when we train trees on each of these data sets, we would get n different type of trees. So each tree would be slightly different from each other, but still would be training on the entirety of the data set with slight differences. Now to make the trees even more different from each other, what random forest does is, when the tree makes a decision for splitting, we saw in our cart video that a tree would consider all the features and chop iteratively go through all the features and try various chops at various levels and select a chop which gives the best possible reduction in Gini impurity. Now, what random forest does is, instead of allowing cart algorithm to go through all the features, it imposes some constraints. So instead of all the 10 features, imagine us using only the first 7 features for making different chops, and only among these 7 features the cart algorithm will choose the best possible split, and it splits. And this happens at every node. So every time cart algorithm does a split, there is some constraint imposed on the number of features that are available to cart algorithm on which it's going to attempt chopping and then seeing the Gini gain. Now, combined with what I said previously, that each of the tree was trained on a part of data which was sampled with replacement, combine that with this constraint on cart algorithm considering only few of the features at every branching, this makes every tree within the forest even more different from each other. Now, this allows us to create a rich and diverse forest where each tree is very different from each other. Now, so this is our data set. To provide a quick recap, we have a data set. We create multiple sample training data sets from one data set by sampling from it repeatedly by replacement. So that results in each of these resulting data sets a little different from each other. However, each might also have some repetitions of the number of rows. So we end up with multiple data sets, each slightly different from each other. And then on each of these data sets, we train a cart. A decision tree is allowed to grow, but at each branching, we make available only a few features, a few randomly selected features. Now, this causes these trees to be even more diverse, and the way these trees grow would be in a very, very different way. Now, if we grow a forest of these trees, we might end up with multiple models, each of which is a decision tree. However, each of it is very different from each other. Now we take our test data set and pass it through each of these models, gather all the predictions, and then we combine, and this is how we get a random forest. And in our next video we would understand, while decision tree in random forest, what we have seen is we stack these trees together in a parallel fashion. And in our previous video I said there is another configuration possible where we stack these in a serial order. So in our next video we would discuss this serial configuration, which is also known as boosting. And once we have covered bagging and boosting, we would end the series with a final video with a hands-on example worked out covering all the techniques we have learned so far. Thank you for watching this video. If you liked what you saw, then please consider subscribing and liking these videos. Thank you.